All right, let's look at these last two problems. These are very similar to the ones in the previous section, except for now they're involving some of the new trig functions. So let's do this. If cosecant is equal to 5 and theta is in quadrant 2, find cosine theta. All right, so if cosecant is 5, that means that its reciprocal sine theta is 1/5. And it's in quadrant 2, so I'm going to draw it over here. Remember, we use our reference angle when we talk about opposite and adjacent. So if sine is 1/5, the opposite side is 1, and the hypotenuse is 5. So now the adjacent side here I'm going to call b, and I can find that using the Pythagorean theorem. B squared plus 1 squared equals 5 squared. So that gives me b equals, well, 25 minus 1 is 24, square root of 24. And I can break 24 up. The biggest perfect square that goes into 24 is 4. So let's factor this into square root of 4 times the square root of 6. So that gives me b is plus or minus, I should have had that on here as well. B is plus or minus 2 root 6. Now, since we're over here in the second quadrant, B is the x-coordinate of this point. So we should go with the negative one, negative 2 root 6. So that means my cosine of theta is going to be the adjacent side, which is this, over the hypotenuse. So my answer is negative 2 root 6 over 5. Now this next example is similar. They don't, well, they say if cotangent theta is 3/7 and cosine is negative, find sine and cosecant of theta. All right, so they don't tell us which quadrant it's in, but they give us enough information to figure that out. Cosine, or rather cotan, is 3/7, so that tells us that tangent is 7/3. All right, cosine is negative, so we can look at our quadrants and figure out A, S, T, C. Now notice tangent here is positive, so that means that it's either going to be this quadrant or this quadrant. It can't be either of these. Then also, because cosine is negative, we know that here in the first quadrant cosine is positive, so we can get rid of that one. This tells us that we have to be here in quadrant 3. All right, so now we'll draw this in. Tangent is, well, I'm going to draw in my triangle in quadrant 3. This is my reference angle. And tangent is 7/3, and 7/3 is the opposite over adjacent, because of SOHCAHTOA. So the opposite side from here is 7, and the adjacent side is 3. Now really, since we're in the third quadrant, those are the coordinates of this point. So both of these numbers should be negative. Now we're supposed to find sine and cosecant. Sine is opposite over hypotenuse, so we've got to work out that hypotenuse. And we can get that just by using the Pythagorean theorem. C squared equals A squared plus B squared. So let's see, that's 49 plus 9 is 58. So let's see, and C, it's always positive. When I take this, I get C is plus or minus the square root of 58. But the hypotenuse on here is always positive because it's the distance from this point to the origin. So let's see, 58. Can we simplify that at all? I don't think so. 58 divided by 2 is 29, so no, we can't simplify that. So C is just square root of 58. So the sine of theta is going to be opposite over hypotenuse. So that's going to be negative 7 over root 58. And cosecant theta That's just the reciprocal of sine, so that's root 58 over 7. And it doesn't matter if we put the negative on top or bottom. So that's this problem.